Okay. So now, this week's syllabus starts with the energy stored in a capacitor. Okay, no downside heading. Energy stored in a capacitor or condenser. In general, it is denoted by the symbol U. Okay, now listen me first. We consider a parallel plate capacitor whose capacity is C with no charge on it. Q is equal to 0. Initially, there is no charge. Let us consider. Now, a battery is connected between the plates. This is the initial state at t is equal to 0. This is the intermediate state at t is equal to t. Now the charge on this is, let us say, plus q on this, minus q on this. Why? Because this plate is connected to positive terminal of a battery of potential V, and this is negative. Now at this intermediate state, let us say, the potential difference between the plates is V dash. Okay, and this capacity is equal to C. Now finally, final state, the charge on the plates now becomes plus capital Q. This is minus capital Q. This is plus V. This is minus. So this also becomes V. Final state means this potential difference between the plates is equal to the supply voltage. But here the potential difference between the plates V dash is less than the applied voltage. That is known as intermediate state. This is the final state. Okay, these are the three situations. This is initially at time t is equal to 0, there is no charge on the plates. Now we connect the battery across the plates, and during the charging at an intermediate state at t is equal to t, the charge on the plates is equal to plus q, and charge on this plate is equal to minus q. So here q is the charge on the plates. Now in the final state, the potential difference between the plates V is equal to the applied voltage V, then it is known as final state. So here, this initial charge on the plates is 0, final charge on the plates is capital Q. Okay, is it clear? Or any doubt in this process?
It's clear, sir.
Okay. Intermediate state means during the process of charging from initial to final, this is the middle state. That is known as intermediate state. Here in this state, already the charge plus Q is present on this, minus Q is present on this plate. Due to the charge flows from battery onto the plates, the charge already present on the plates opposes the further charge given to the plates by this battery. Is it clear?
Yes, sir.
That's why some work is done by the battery in charging the plates further from 0 to plus Q, or from plus small q to plus capital Q on one plate, minus small q to minus capital Q on the other plate. Is it clear?
Yes, sir.
So here in this intermediate state, at T is equal to T, potential difference between the plates, potential difference between the plates is equal to the formula V dash is equal to the charge on this is equal to Q. The capacity of the capacitor is C. No, the capacity is C. The capacity is C. It does not change. That's why V dash is equal to Q by C. Is it clear? By the definition of capacity. C is equal to Q by V dash? No, that's why V dash is equal to Q by C. Since the Q is equal to 1, C is equal to Q by V dash. General definition. From this we write V dash is equal to Q by C. Here, due to this potential difference V dash, field between the plates, electric field is developed in it. So here, work should be done in giving the additional charge, small additional charge dq to the plates by the battery. What is the work done in moving a charge, let us say small charge dq from one plate to the other plate? Then only it gets charged. No, actually charge is moving from negative charge to positive charge. dq, let us say here like this, from charge, small charge is flows from minus q to plus q through a potential difference V dash. Then some work is said to be done. What is the formula for work done in moving a charge through a potential difference P? Electrostatics lo vastundamma. Work done is equal to QV formula. Here we use the QD dV formula, V dash dq anamata, like that. QV formula. Is it clear or not? Work done. Work done in moving a charge through a potential difference is equal to QV formula. Is it clear?
Yes, sir.
So once we respond quickly, Amma. If there is no disturbance in our surroundings, please unmute your microphone and give quick response, Amma, so that I will proceed. Okay. So V dash is equal to Q by C. The work done in adding a small charge dq to the capacitor is given by, what is the formula for it? Now, dw is equal to
V2.
V dash dq, right? Very good. Here this is V dash. Between the base V dash, it is less than V. Why? Because this is intermediate state, not final state. In the final state, both are equal. So which is equal to, what is the V dash value? Q by C into dq. Therefore, the total work done in charging the capacitor from 0 to capital Q, in charging the capacitor from 0 to plus Q, or simply Q, is given by, what is the, how can you get total work done? This is small work done. How can you get total work done, W?
By integrating, sir.
By integrating, very good, very good. By integrating the small work done between the limits 0 to Q, we get the total work done. Integral 0 to Q, dW is Q by C dQ. Very good. Here C is constant taken out, and integral 0 to Q, small q dQ. But what is the expression for the integral Q dQ? What is the integral formula of x dx? Which is equal to 1 by C into integral
Q by 2.
x dx is nothing but x square by 2. This is the general formula for integration of x dx with respect to dx. Okay, so here instead of x we use q. That's why this integral q dq can be written as
Q square by 2.
very good. Q square by 2 between the limits 0 to capital Q. This can be written as 1 by 2c into, By substituting the upper limit, we get capital Q square minus. By substituting lower limit, we get 0. Is it clear?
Yes, sir.
Okay. Shall I rub this all these diagrams 3?
Yes, sir.
1 minute.
Okay, note down. Why this small work is done by the battery in giving an additional charge dq? Why? Because the charge already present on the plates opposes the charge given further to it. Why? Because already plus q is there. Here plus dq should be added. Here already minus q is there. Minus dq should be added. That's why here already the charge, like charge is present on the plates, which opposes the further like charge. That's why this work should be done by the battery in charging the capacitor.
Done, sir.
Okay. Therefore, continuation further. W is equal to, this can be written as Q square by 2C. But here we know that Q is equal to C, we know. Final stage, the final stage. That's why C square V square by C. Once CC gets cancelled, we can write half CV square. Since Q is equal to CV. And also this can be written as which is equal to, here according to this, C is equal to Q by V. By substituting C is equal to Q by V, Q gets cancelled, this denominator V goes to numerator. So this can be written as QV by 2. Since C is equal to Q by V. So by substituting C is equal to Q by V, we get this formula. This is the expression for work done in charging the battery. Is it clear?
Yes, sir.
Any doubt? Okay. Now here, electric field is a conservative force field or non-conservative force field? Anyone? What is the work done in moving a charge in a closed path in electric field? Anyone? No, it is 0. It is independent of path. In a closed path, work done in electric field in moving a charge in a closed path is 0. That means conservative force, electric field is conservative force field. In conservative force field, this work done is stored as electrostatic potential energy. Now here we call it as energy stored in the capacitor. Simple. Here there is no kinetic energy in the conservative force field. That's why conservative force field work done is related to potential energy only. This work done is known as electrostatic potential energy and is called here in this topic is energy stored in the capacitor. It is denoted by the symbol U. Therefore, the energy stored in the capacitor is U instead of W, we write U. That's all. Is equal to Q square by 2C, which is equal to half CV square, which is equal to half QV. Simple formula. Is it clear? All of you?
Yes, sir.
Students?
Yes, sir.
Okay, note down. Next one. Since the electric field is conservative force field, conservative force field. The above work done, is stored as electrostatic potential energy and is called energy stored in the capacitor. Capacitor or condenser. It is denoted by the symbol cap. Therefore, capital U is equal to Q square by 2C, which is equal to half CV square, which is equal to half QV. This is the total energy stored or electrostatic potential energy or energy stored in the capacitor. Note. Next point. But sigma is equal to, what is sigma? What is sigma, ma? Anyone tell me? What is sigma?
Charge density, sir.
Sorry, surface charge density. Okay, volume charge density, surface charge density, linear charge density. Linear charge density means lambda, denoted with the symbol lambda, charge per unit length. Surface charge density means charge per unit area. And surface charge, volume charge density or simply charge density means rho. That is charge per unit volume, not potential. This is volume V. Like that we define two charge densities: linear charge density, surface charge density, volume charge density per unit volume. This is taken in the linear charge distribution. This is taken in charge distribution on a plane surface like a plate like that. This is defined in case of non-conducting materials, non-conducting sphere, solid sphere, etc. The charge is distributed throughout its volume. Okay. So here in this case, here in parallel plate capacitor, the plates are made up of with conducting materials. That's why the charge given to the plates remains on the surface. That means per unit area. So here sigma is equal to charge per unit area of the plate. So here this implies we can write Q is equal to sigma A. Therefore, this U can be written as U is equal to Q square means sigma square A square by 2C. Sigma square A square by 2C. But here C is equal to, we know that C is equal to epsilon naught A by D now. We can write like that. And C is equal to epsilon naught A by D. Is it clear? So this A gets cancelled with each other. Now this can be written as half sigma square by epsilon naught into A into D. A into D. What is A into D? What is A here? This is a plate like this. This is another plate like this. The separation between them is plates is D. The area of each plate is A. So A into D is equal to
Volume, sir.
Volume, very good, very good. Volume of space between the plates or electric field. Okay, that volume, the total energy stored per unit volume is known as energy density. We call it as energy density also. Important formula, energy density of electrostatic field and down. Okay, so therefore this implies energy density. Energy density. It is denoted by the symbol small u is equal to total energy divided by volume, which is equal to U by AD. volume of the field. Here, uniform field is produced between the plates, no, like this. The energy stored in this field is given by U by AD per unit volume. Why? Because in general, energy in electric field and energy stored in magnetic field is measured in terms of energy densities only. Here in electric field, energy density is using like this. So this implies small u is equal to, by substituting capital U here we get U by AD is nothing but we get sigma square by 2 epsilon naught. This is the energy density. This is another important formula. But what is the electric field between the plates of a parallel plate capacitor? If sigma is the charge density, tell me. Anyone? E is equal to my electric field man completed no already. What is the electric field due to charged plane sheet? It is independent of distance and is given by sigma by 2 epsilon naught. But here in a parallel plate capacitor, two plates are there. Due to this electric field in between there is sigma by 2 epsilon naught. Due to is also sigma by 2 epsilon naught. So here, next point. But electric field between the plates E is equal to sigma by epsilon naught. This implies sigma is equal to epsilon naught. Therefore, energy density U is equal to energy density small u is equal to, according to this formula, epsilon naught square E square by 2 epsilon naught. So if this epsilon naught gets cancelled with each other, this implies energy density U is equal to half epsilon naught E square. This is one formula, this is another formula of the energy density formula. While doing objective problems, we use this, all these formulas. One should remember this energy density. It is the energy, electric energy stored per unit volume of the space between the plates, parallel plate capacitor. If dielectric is filled between the plates, then what happened? Tell me, how can you write the energy density now? Come on, draw this diagram. Here, a dielectric of dielectric constant K is filled between the plates. Then, if a dielectric is filled between plates, then what is energy density? Instead of epsilon naught, we write epsilon naught. Sigma square by 2 epsilon, which can be written as sigma square by 2k epsilon naught. This is one formula. According to this, U is equal to half epsilon E square. Half epsilon E square. My current is gone. Inverter. Here shade is appear no. No problem.
It's not visible, sir.
Here already completed. Now this one all of you noted or not? This one.
Yes, sir. Complete.
Okay. So shade is there. Current gone. The circuit light is the inverter. That's why shade will appear here. Okay, ma'am. So here, how can you write this formula? And in another form, what is the value of epsilon here according to this? Ma'am, half K epsilon naught E square. This is in terms of electric field E, this is in terms of surface charge density sigma. Where sigma is equal to the formula? Where sigma is equal to Q by E. That is important. If charge is given, we use this formula. If electric field between the plates is given, we use this formula. Here K is dielectric constant. Here this is with air field, air place between the plates. Here this is with air, with any dielectric medium between the plates. Okay, ma. Important note point. Here in charging this capacitor, what is the work done by the battery? Now tell me. In the final state, the potential difference between the plates is we know. Here work should be done by the battery in charging the capacitor. Why? Because here the charge present all the way on the plates of the capacitor opposes the further charging on it. So here battery do some work in charging the capacitor plates from 0 to capital Q. What is that work done? In moving charge Q between the plates from 0 to capital Q. Here the potential difference between the plates is equal to potential of the battery, which is equal to how much V here. So what is the work done by the battery in giving charge Q through a potential difference V? Work done starting with QV formula. Is it clear? My students?
Yes, sir.
Quicker respond avallamma. So note important note point. Work done by the battery in charging the capacitor. In charging the capacitor from 0 to capital Q is W is equal to QV. But in which, what is the energy stored in it? Capital U, which is equal to you know. Here, what is the energy stored?
Half QV, sir.
Right, very good. But the total work done by the battery is QV, in which half of the work done is stored as electrostatic potential energy. Now, the remaining half work done, where it will go? Tell me, do you expect anyone? No. But U is equal to Q square QV with a half QV. Therefore, the remaining work done is wasted in the form of heat energy. That is important. Therefore, the difference is wasted in the form of Therefore, heat produced in the process of charging, heat produced is equal to W minus U. Heat produced in general denoted the symbol capital HM. Let us say that means QV minus half QV. This implies heat produced is equal to half QV. So here heat produced is equal to the energy stored in the capacitor. So half of the work done is stored as elastic potential energy. Remaining half of the work is wasted in the form of heat energy. Is it clear?
Yes, sir.
Okay, very good. So important note point. Formula is very, very important. Okay, this is about energy stored in a capacitor and energy density of electric field between the plates of the parallel plate capacitor. Now, let us discuss about effect of dielectric in various factors on parallel plate capacitor. My completed this lower part. So let have this one. Students.
1 minute, sir.
Okay. Note. The effect of dielectric on various factors of a parallel plate capacitor, PPC. Was it completed? This one?
Yes, sir. 1 minute. Done, sir.
Oh. What is the capacity of air filled capacitor? What is the formula for the air filled capacitor? Capacity of an air filled capacitor. AC naught is equal to epsilon naught A by D. Okay, here we have two cases. Case one. Dielectric is introduced between the plates of parallel plate capacitor without disconnecting the battery. That means here, initially, this is a capacitor connected to a battery like this. Here, this applied voltage is V0. Now, this capacitance is equal to C0. Here, charge flows like this. Now, without disconnecting this battery, dielectric is filled between the plates like this. Here, a dielectric of dielectric constant K is filled between the plates like this without disconnecting. Then what happens? That is important. This is V0. Now, what about capacity? C is equal to how much? Already. Right. C is equal to KC0. K epsilon naught A by D kadamma. K epsilon naught A by D, which is equal to KC0. Here, the charge on the plates is equal to Q0 plus Q0 minus Q0. Here, since the battery is remains present in it, the charge on this also plus Q0 minus Q0. Our charge increases. Charge flows on this node. Here, potential difference is V0 only. Here, potential difference between the plates is also V0. So, first case 1, without disconnecting the battery. Without disconnecting the battery. That is the first case. Dielectric is filled. Then, this is happened.
Sir, we cannot see that line. Yes, sir.
And now it is clear.
Yes, sir. Yes, sir.
What about potential difference? Is it same or not? Tell me.
Same, sir.
Same.
Why? Because battery remains the same in the circuit itself. Now the charge on this is equal to plus Q, charge on this is equal to minus Q. That is the case. So here in this case, first point. Potential difference between the plates remains the same. That is important point. That is V0 is equal to constant. That is one important point. Next, what about capacity C? Capacity C is equal to K epsilon naught A by D, which is equal to KC naught. So capacity increases to K times. That is C increases to K times. Next, charge on the plates. Q is equal to C. KC naught V naught. This can be written as KQ naught. Why? Because this Q naught is equal to C naught V naught. No. That's right. So charge on the plate increases to K times again. Therefore, charge increases to K times. Without disconnecting the battery, if the dielectric is filled between the plates, the charge on the plates increases to K times. Capacity increases to K times. But potential difference, the big difference between the plates remains the same. Next point. What about electric field? What is the initial electric field? Initial electric field between the plates. Tell me. Anyone? E naught is equal to. What is the relation between electric field and potential? V naught by D now. Where D is the distance between the plates. Therefore, what is the final electric field? Final electric field.
Same, sir.
Right, very good. Final electric field E is equal to V by D. V is also V naught only, no? V naught by D. Therefore, E is equal to E naught. That is, field remains constant or remains the same. Field remains the same. So potential remains the same, field remains the same. But capacity increases by K times, increases to K times. Charge on the plates increases to K times. Is it completed? Next, what about the energy stored? No, tell me. What is the energy stored? So I got this one.
Yes, sir. Will increase K times.
Right. Again, find out next point, continuation. New energy store. U is equal to half C is half QV. That is best. Half QV. Half into KQ naught into V is also V naught. No. This can be written as, we can write this as half Q naught V naught. This is initial energy stored. This implies U is equal to KU naught. That is increases to K times. Okay, the actual initial charge is Q naught, final charge is Q. What is the additional charge flows?
What's the
Difference between them. Additional charge flows on
Q and Q?
is, let us say delta Q is equal to Q minus Q naught. Which is equal to Q is KQ naught minus Q naught. This implies additional charge flows onto the capacitor plates is K minus 1 into Q naught. So to add this additional charge, work should be done by the battery in sending the additional charge. So therefore, additional work done. Additional work done by the battery is delta W is equal to delta Q into V naught. Delta Q is nothing but here K minus 1 into Q naught V naught. That is the additional work. This is the work done by the battery. In general, work done by the battery into K minus 1 gives additional work done when a dielectric of constant K is filled between the plates. In general, K is more than 1, not less than 1. For air, it is approximately 1.
Excuse me, sir.
Other dielectric materials, K is always greater than 1. For metals, what is the value of K?
0, sir.
For metal conductors, what is the value of K?
0.
Not 0, it is infinity. Okay, man. Remember. Okay, this is about case 1. This lower part completed.
1 minute.
Not. Here, effect of dielectrics lo cheppe untaru kadamma. If a metal slab like brass slab is introduced between the plates of capacitor, the capacity of the capacitor is given by here K is taken as infinity for metal slab. That is very, very important. So if a metal slab of thickness T is introduced between the plates, then what is the capacity? Last week syllabus only, no? Just don't write. Here, this is a metal slab. This is metal. So the dielectric constant is infinity anamata. This distance is d. If any dielectric is introduced, the capacity C is equal to epsilon naught A by d minus T into 1 minus 1 by K kadamma.
Yes.
If metal slab is used, K is equal to infinity. 1 by infinity is equal to how much?
0.
1 by infinity. Infinity is equal to anything by 0. Okay. So here anything is equal to 0 into infinity 0. That's why 1 by K, 1 by infinity is equal to 0. So this can be written as epsilon naught A by simply D minus T. That is the capacity of a parallel plate capacitor with the metal slab between the plates. So the capacity increases or decreases now by introducing metal plate. Denominator decreases now. That's why capacity increases.
Increases.
So which is greater than C naught without without a metal plate like that. So here, if any metal is given, K value should be taken as infinity. That is very important. For air, it is 1. For all dielectric, it is greater than 1. For metal conductors, it is infinity. Less than 1 is not possible for any material. Okay. Now, time is over. May I completed this part also? Upper one.
1 minute.
No. After disconnecting the battery, dielectric is introduced. Then, so here this is a battery charging like this with V0 here. This is the capacity C0 and the potential difference is V0. So charge flows in this direction now. Battery is disconnected and the space between them is filled with a dielectric like this. Simple. Now the capacity is C. And here charge on this is equal to Q0, charge on this Q0. Charge on this is equal to Q, charge on this is equal to Q. Here potential difference between them is equal to V0. Here potential difference between them is equal to V. Now we can find out all the points in the previous case here also. What about Q? Q remains same or different?
Same, sir.
Why? Because there is no battery, no. That's why no further charge flows onto the plates. That's why Q is equal to Q0. That means charge remains the same and so on like that. Okay, ma'am. We will derive all the cases like in the before case in the next class. Okay, my time is over now.
Yes.
Okay, ma'am. Is it clear this class?
Yes, sir.
Okay, ma'am. By the way, I am Srinivas Reddy, newly joined, ma'am. Today onwards, will take up your track 2 classes. Okay?
Yes, sir.
Okay, okay. Bye.
Thank you, sir.
Have a nice day. Okay.
Thank you, sir.
Okay.